Welcome, folks. As you know, my name is Ted M. Young. I am a longtime Java fan, trainer, coach, live coder. So I've been doing Java for 30 years. Um, Currently, I do individual and team coaching for basically helping teams make their code more testable. So one of the things that is underpins almost all that I do and how I think about design and architecture is from a point of view of testability. How do we make our code more testable? Things like that. Um, uh, just general note, if you want your webcam on, that would be great, but no pressure. If you want to leave it off, that is fine as well. But sometimes it's nice for me as a presenter to see folks' faces. And so I've been doing event sourcing for a couple of years, and there's a one of the things that's always helpful is when you learn stuff that you teach it as well. And I gave this presentation last month at the Dev Connect conference in Colorado, which was great. Had lots of good questions, and so welcome to my TED Talk. I always forget to say that, but as Ted is my first name, I can say this is a TED Talk, so welcome. And you can see all the places you can find me. So ted.dev is my website. As mentioned before, recording of this will be available. So if you don't want your face and or voice to appear on the recording, then you probably want to mute and hide yourself. But otherwise, the recording will be available. I will make it available at the ted.dev/talks. You'll see the recording, slides, source code. So the source code is fully open source, and it's actually, I continue to work on it, as I mentioned, on my live coding stream. So one of the things we're working on now is what are called projectors, and I'll talk a little bit about that. I'm also doing another talk on testable architecture. So as I mentioned, testability is the underpinning for how I think about coding and design and architecture. So there's an online session with the Calgary Software Crafters Group. And so you can go and sign up, and I'll throw that into chat for the link. And so that's coming up on December 10th. Probably too late for those of you not in sort of east of the Eastern time zone, so Europe and so on. It's probably going to be too late for you. It'll be like 2 a.m. for at least for some of you, but that will also be recorded, and I'll let you all know that it's available. All right, let's see. Why is that? There we go. So I don't want this to be just me talking outwards, even though I do that a lot. And so if you have questions, ask them, throw them into chat, raise your hand, whichever you prefer. I'll monitor chat, and if I see a question pop up, I'll either acknowledge it and say I'm going to talk about that, right? So I reserve the right to defer the question if I know I'm going to get to it. If not, then I'll answer it. In addition, the time that I've set up for this, it was 90 minutes, because when I did the talk, it was about an hour and a quarter. So 90 minutes will give us time for questions. And at the end, I will basically hang out until there are no more questions. So if you want to discuss further and deeper, then there's going to be time available for that. All right. So when I started looking at event sourcing, one of the things that I was looking around for were frameworks and libraries. And so in Java, unfortunately, and I find it to be a little strange that really the only framework that is gotten any kind of widespread mindshare is Axon IQ. it's really a framework. You have to buy into it. And there's a lot there, and it's well supported, and the folks who are behind it are knowledgeable, but it is big. And I think from a learning standpoint, it's overwhelming. So it's not where I would start. But there's a couple of other ones. There's OpenCQRS, but that's coming from a vendor that has their event store database product. And I'm always a little wary of being tied to something like that. But the clients and some of the other stuff is open source. Uh, in the .NET world, there's Martin, and there seems to be a lot more event sourcing going on in the .NET world that I just find fascinating from a social, point of view, of like community point of view. Is like, why is .NET, adopting this, and I don't see as much talk about it in the Java world, other than sort of, Axon IQ. PHP has event sauce, uh, which is always fun to say when you're used to saying event sourcing. Um, and I've learned a lot from actually just looking at their documentation. So looking at the documentation for both Martin and event sauce was interesting. Um, I am obviously writing code to do event sourcing from scratch, and we're going to look at how you implement it. It's the technical parts are not that difficult. What's difficult is the mind shift, and that takes a while to get used to. If you're familiar with CQRS and you've done that without event sourcing, then the shift is going to be a bit easier. But one of the big shifts is this idea of not using the same tables for reading and writing. That's like the fundamental thing. So as I mentioned, I'm going to do this from scratch, right? So I'm not using any libraries other than Spring for Spring Data JDBC for storing rows in a table. But you could totally do this using almost raw JDBC. There's not a lot there, and so really want to come at this from what does it look like to implement this from scratch, and then how does that help us understand what's going on. So the first question is, how do we persist data? So we'll talk about what we'll call traditional ways of doing that, right? The ways we probably do it right now. I'm going to define some of the terms, because terms like event and event stream and event store and all these kinds of things have lots of different definitions in our industry. And I struggle sometimes to come up with better terms, but sometimes it's like, well, this is the only way to describe this. I'm also going to clarify some things around the different architectures or designs or mechanisms that also use some of these terms. And then I'll talk a little bit about the domain for this example application, because one of the things I think is really important for learning and talking about this stuff is having an example application that's non-trivial. On the other hand, it's also useful to have one that's not huge and hard to understand. So Jitter Ticket is my example app for a concert event ticketing domain, and for better or for worse, it has the word event in there, and so event even has now more meanings. You got one from the domain, you got one from the actual event sourcing and other things. So it might not have been the best domain, but it was one that I love going to concerts, and so there you go. And then we'll dive into the code. So it's one of those, like, as I mentioned, like learning how to do this. I think it's for me, it was, I got into this. So there's a project that I'm working on is bringing my TDD game online. So I have a board game called Jitter Ted's TDD game, and I want to put it online so that people can play it remotely. and I wanted to use event sourcing because I'd done a bit with it, and then someone asked about, hey, do you have a simpler example? Because there's a lot of stuff that has nothing to do with event sourcing, but that's in the TDD game online. And so basically I took a detour, and that detour has lasted coming up on almost a year, maybe 9 months. Um, so we'll dig into the code. We'll also dig into the tests, because I think the tests, as I mentioned, I'm all about testability. Everything in this code base and in most of my code bases are test driven. And so we'll look at the test and see how you actually test an event sourced application. One of the nice things is that it's actually really straightforward. So we'll look at that. uh, I'll touch on some related topics, because to cover everything that's in the world of event sourcing would take way longer than just 90 minutes. So there's some stuff about that I've already mentioned, like CQRS. There's some ways of modeling things called event modeling. I'll touch on that a little bit. Then there's event storming, which is not directly related to event sourcing, but is very useful. And there's some nuances between the different kinds of events, and I'll also talk about that. Popular topics also are versioning and schema migration. I'll touch on those a little bit. And performance always comes up. I'll talk about that a bit as well. And there's some other interesting things in the area. Something called dynamic consistency boundary, which I sort of fell into myself, and then found that there was the folks from Axon IQ actually came up with a name for that. There's also decider. There's also privacy issues in terms of what if you need to forget information. So in a typical traditional application, how do we persist data? Often we map our objects to database tables, right? We use an ORM of some sort. Maybe you're using Hibernate through Spring Data JPA, or you're using something like Juke, or different ways of, or sometimes you're just writing raw SQL, which is totally fine. But all of these are trying to map the data that we have in memory that we're operating on to do things, right? So I'm very much, I like a good domain model, right? So I love domain-driven design. I love good domain objects. Those don't always map well to relational tables. And then we sometimes get issues in retrieving them. And depending on the ORM that you're using, you may run into issues, the n+1, select n+1 problem, lazy loading, things like that. I tend to use Spring Data JDBC because I don't need all that stuff. I just want to load stuff. But even there, how do we persist data? Sometimes as an ORM. And this question often comes up. If I have a domain object, for me, it must be fully encapsulated, right? That's the whole point. So I run a book club. We just finished reading Balancing Coupling. And really what that book is about is modularity. And encapsulation is a way of enforcing modularity boundaries. I don't want other parts of my code to know how I store data inside of my objects. Yes, the book from Vlad Kononov. Yes. Really good book, highly recommended. And so one of the issues I always ran into with having this really rich domain model in memory is, how do I get the data out? And then how do I reconstitute it in memory when I need it, right? So typically, some action comes in from the outside. A user says, buy a ticket. So I need to load the console to see, are there tickets available? Is this in the future? Right? You can't buy, it's very difficult to buy tickets for concerts that have already happened, unless you're eBay and selling vintage tickets or something like that. But typically you'd want to load the thing up. Or can this person buy the tickets? and there are all sorts of business rules, but I need that data loaded in memory so I can make a decision. And how do I reconstitute objects, and how do I store them? So we've sold the tickets, and so therefore things like available tickets have to be reduced. If there's specific seats, we have to allocate those, and then we need to save data. But if you really encapsulate your objects, how do you get at that data? And this is the mapping problem. I have come to a solution that I like, which is I basically grab a snapshot. And so the objects provide a snapshot, which is going to be just a simple class or record in Java, and it's just going to be the data. So it's just a bag of data. It breaks encapsulation because now somebody could go and call that method and grab out all of the internal data and futz with it or look at it. It's a compromise. And so what I do is I use a tool like ArcUnit to ensure that the only code that can call that invasive, intrusive method is my database repository. So at least that way I have a test that when it fails, if some code is trying to access that and it's not the repository, then it shouldn't access it, and basically the test will fail. So therefore, I basically then, in a sense, map my domain objects to objects that then get stored in the database. So what does that look like? It looks like this, right? So here I've got a concert service. And so here we want to do some, we want to get it loaded. And so what happens is we basically do a find. That gets forwarded to a repository adapter. So I tend to use a hexagonal-like architecture. It's not pure hexagonal. I do hexagonal plus domain-driven. And so the adapter then turns around and calls the technical implementation. In Spring, this would be a repository interface. Does the find, and it does the select. It figures out how to do select. It then gets a result set from the database. That gets converted by the ORM into some data transfer object. I often call these database objects. And then that gets returned, and then we reconstitute the object, the domain object, from this DTO, and now we've got an object, an entity. In this case, it would be technically an aggregate. So this is the process, right? So we've got a couple of, we've got a transformation that happens sort of behind the scenes by the ORM, right? Takes whatever the result set is and converts it into an object. And then we take that object, because it's just a bag of data, and reconstitute our object that has all the behavior around that data. And that's how that works. This works well. But there is a problem. And maybe you don't encounter this problem, but often what people ask is like, why should I do event sourcing, right? State sourcing, CRUD sourcing, whatever you want to call it. I sometimes call it overwrite state sourcing to emphasize the fact that we are overriding any previous data that was there. Is we have no history. Information gets thrown away. Now, if you don't care, and if you never care about history, that's totally fine. But we don't have any knowledge of how or why the state changed, or when sometimes. And what we end up doing is we often add stuff. Maybe we've had long experience of like, oh, somebody's going to ask us for the audit trail or the history of these changes. So let me go write extra code to store that. And maybe you have some automatic stuff that the database does, or maybe your ORM, you've configured it in a way so that it automatically saves off changes to another table. But these are special one-off things, and you have to know them up front, right? So, right, we've got a concert. It's got an ID, it's got a version, right? So we use that for optimistic concurrency. And then we decide that we need to change the ticket price because somebody did a typo and it shouldn't have been 135, it should have been 35. Version number changes, we persist that. We figured out a way to fit more people in, so we increase the capacity. from 100 to 120 tickets available, right? But we've lost information about what's why is it 120? You know, somebody said I thought it was 100. What happened? What's going on? Who changed that? When did it happen? Yeah, and so Hussein mentioned sort of, you know, auditing is important in some domains where you must have an audit trail of what happened for legal compliance, whatever purposes. And unless you, again, explicitly code for this, that information is gone. Right? We have no, we've lost all those changes. All we see is what it currently is. We know that it's version 3, so we know there were 2 previous changes. We just don't know what they are. And again, we might have long experience. We might even have the requirements that we need to save these things as an audit trail, but then now that's extra work, right? That's extra work that, again, maybe you have a good library or the framework and configuration can set that up, but you have to know which pieces need that audit trail, because you probably don't want to do it for everything, or maybe you do. So there are 3 fundamental pieces in event sourcing. There is the past, things that have happened, and we call these events. They are in the past. They are facts. In fact, I almost prefer to use the word fact than event, but it's an event. The present is what is the current state. And then sort of future kind of idea is that we then want to do something against the current state. Right? So command is a request to change state. That's really all it is, right? And if you know command queries, you know that there are 2 types of things. Commands are requests to change state, and queries is like, what is the current state? Another way of looking at this is commands. I always, more and more, I think of systems as basically being big state machines. And so we're pushing it through different parts of that state machine through commands. Sometimes they're allowed, and sometimes, nope, no concert tickets left, so you can't buy tickets, or there aren't enough for you. Too bad, sorry. So an event is a fact, something that has happened. Not will happen, not might have happened. It happened, right? Customer registered, that happened. And we have the information around that customer, probably their name, probably their email address, maybe some other information, but that's a fact. And so you'll see that like in most systems that use events, they are in the past, because they're recording the outcome of some decision that was made. Concert scheduled, ticket purchased, ticket transferred. All of these things are facts. They happened. They may have happened incorrectly if we have a bug, or maybe we change other things and it turns out that we need to somehow undo them. But the fact is they happened, and you can't just erase history and replace it with something else. So these events are generally considered immutable. They're facts. They're stored somewhere, and depending on the context, sometimes they're temporary. In event sourcing, they are persisted always. So those are events. And this generally applies to any place that's using event, whether it's event sourcing, event-driven architecture, event streaming, all these kinds of things. They are generally like, this happened. And it could be sort of passive things like temperature changed, right? So if you got sensors and IoT and you got lots of events, they could be just like, this is the temperature at this point. Then there's state. And this is our data model needed by the application so that our behavior can do stuff, right? So we want to see what is the current state. This is the current state of the system. It has data, and somewhere behind that is behavior that then the command executes against. So it's a request to change state, and these are often sort of imperative. Hey, go schedule this thing. Go reschedule the concert. Purchase tickets, right? All these are commands. They may fail, or they may succeed in odd ways. And by odd, I mean sort of you purchase tickets and there aren't any available, but it's going to sit there and wait for a bit, and maybe some will be freed up. But all of these can fail and can result in, sorry, you can't reschedule this concert. It already happened. Can't reschedule this concert. It's only 24 hours away and we can't do that. Purchase tickets, there aren't enough tickets available. So these are requests to change state. And whether that request is allowed is the behavior of our system. So there's sort of two general things that I like to think about in event sourcing. There's sort of two pieces for state to change. And this is it. This is the hard part. I'm used, for decades, I always thought of good OO as like the object is there. I execute a method against it. And then now that object state might have changed. If it was allowed, it changed. And now that's it. And I can store it and so on, but that's it. If they're sitting in memory for a while, I've done desktop systems, and so stuff is sitting in memory for a while. And so you make the change, it now has the new state. Make another change, it now has the new state. Right? Sort of, it feels like one thing that I do. I execute a command, and now I can ask the object, hey, what's different? In event sourcing, this is split into two pieces. Commands generate events. Not always, right? Because there's always a possibility a command could be rejected. But if it's successful, a command generates one or more events. Typically one, but it can generate two or three, probably not more than that. So reschedule a concert, if it's successful, generates a concert rescheduled event with the information that we need to reconstruct what exactly happened, right? Probably the new date and time. If the artist changed, hopefully it didn't change drastically, but maybe we added a new headliner, it would be, update, artist updated or opener added, right? And these are domain terms, right? These are things that the business could understand. But again, if we can't reschedule a concert and that behavior is, again, up to the business, maybe we're allowed to change it. Or maybe, right, there was a snowstorm and the band couldn't make it over the mountain because they didn't, because their bus can't make it. And so we've got to reschedule it. Or no, it's starting in an hour, we can't reschedule it, right? So whatever the business rules are, we implement those. And so in this case, the command is not successful because remember, it was just a request. And so we don't generate events. Or we might generate an event of reschedule attempted, right? So even failures can also generate events. It depends if that information is useful or not. Yeah, so so hopefully that addressed your question, George. If it's important to understand that this was attempted and failed, then you record it as an event. If nobody cares, and I think probably most of the time, again, it may depend on, do you have regulatory compliance? And there's potentially security things, like somebody attempted to do something. Those possible, but in general, you're probably not going to record the failures. But again, this is up to the business. Do they care about that stuff? And so Sam asks if there are multiple events generated, are they part of a single transaction? Absolutely, yes. Because they are the actual state that changed, what happened. And so it must be part of the same transaction. But we'll look at that. And this is actually one of the benefits of event sourcing, is it actually makes some of this stuff easier. So we've generated events, but that in-memory object state actually hasn't changed yet. And so when we execute a command on an object in memory, events get generated, and then immediately they get applied. So commands generate events, and then events update state. And it's important to separate these because when we want to rebuild that object in memory so that we can take it from storage and rebuild it in memory so we can execute a method against it, we need to have the current state. Well, how do we build that state? We take all the events that ever happened and apply them, and now we have the current state. Now, a side note, I am talking about all this stuff from an object-oriented language point of view. I do this in Java. It's going to be similar for other object-oriented languages. For functional languages, and whether JavaScript falls under that or not, it's a debate for another time. But for languages like Elixir and so on, it's slightly different. You're not rebuilding the object and it has the behavior on it. You're still rebuilding the data, and then you're basically passing it into a function. There's a book, and I'll have some resources at the end for you to look at. There's a book called Real World Event Sourcing that uses Elixir for the code in the book. And so you can sort of see how that works from a functional standpoint. Really good book, and I'll mention again later. So events update state, which means if we want to get the current state, we need to grab those events and then apply them. So we get a concert rescheduled event, we update, and now the new state of the concert in terms of its date is now November 2nd, which is now already in the past. And so you don't just have one event, you have multiple events. So if we want to build the current state of what is the current state of this concert entity, right? I've got an ID. What's the current state? Well, if there were these three events, then this is the current state. The concert was scheduled, right? So we saw this before from the data point of view, but now we're looking at it from a series of events. Concert was scheduled. The band's name is Sonic Waves. They're playing on October 30th, $135 a ticket, and there are 100 ticks available for this venue. Then we changed the ticket price, and then we rescheduled the concert to November 2nd. And so we apply these events in order. So order is critical, but it's also not that hard. Events, databases and other mechanisms are really good at generating numbers that increase. You don't have to worry about there not being gaps as long as it's increasing and you can get the order correct. That's all that matters. And so when what we call project, sometimes called fold or apply, whatever term you want to use, we are taking all of these events and just applying them. And so we start with an empty object, we apply events, it changes its internal state, apply another event, it changes its internal state, apply another event, and so on, until we get what is considered the current state. So instead of loading the full state from the database and saying, here's my state in memory, you load the events, apply them, and now I have the current state. So a projection is a function that constructs our data by replaying events from the event store. The event store is just some place that I can store the events immutable in a specified specific order. And that sounds like a log, right? An append only immutable log. And that's it. So it's just record these events in an ever increasing amount, can never change the past. You don't want to because those are facts. They happened. It might have been a bug. We might not have, we might have had an off by one error and shouldn't have sold that last ticket because we were over capacity. That's a bug, but the fact is it happened. It was allowed to happen. It happened. We may need to go and create a compensating event to adjust for that. So it might be we have to refund their purchase. Or we might go in and increase the capacity so it's no longer sort of a problem. We've checked with the fire department and they're okay with that. And it is exactly like an immutable ledger. And so for those of you who've ever done accounting systems, I worked on a billing system for insurance software, and we implemented double entry accounting where you never, ever change the past. You just created new transactions to adjust for any mistakes that happened. And so an event store is this place to store it. And you can store it in a comma separated file. And actually the jitter ticket has an implementation of that stores it in comma separated file. If your file system is fast enough and structured in a way that it's quick to append, then that works great. Some file systems have to go and seek to the end, and that can take some time, and then you have to append, and then that can take some extra time. So it might not always be a great place to store it, but you can do that. You can also obviously store it in a database, but here now you're not using any of the relational features. It's a single table, to a certain extent, ever growing, that you're going to store all the events in. Now, each event is going to be different in structure, right? So if we look back at these events, the ticket price changed has probably the ID for the concert that we're talking about, and then the new price. And that's it. So it's a tiny event. Rescheduled might be a bit larger because it has, in addition to the identifier for the concert, it has the new date and time and when the doors open. So 2 or 3 fields. The concert scheduled event itself might be much larger, right? It's got the artists, it's got the openers, it's got the date, the ticket price, the maximum capacity of tickets, how many are you limiting purchases for, and a bunch of other information that it might have. And so that event might be large. And so when you're storing it in a table, you are not using a schema that you normally would, right? You might have, different schemas for different objects. Here, all objects eventually get stored as events, and then those events are widely varying in terms of their size and content. And so you probably want a database, if you're using a database, that can handle that. Postgres and similar databases allow you to have a column that is just text. Or JSON, but if you're not generally querying inside of it, so whether you store it as JSON or not is sort of not relevant. But the point is you're not using the schema of the database to define the content, which of course is good and bad, but I think in general, it's the benefits outweigh any downsides. So to me, this is one of the biggest benefits of event sourcing. Ask questions that you didn't know you had when you started creating the system. For example, in the concert ticketing system, how many customers are transferring tickets? We didn't think we needed to know that up front. And so, we implemented the transfer ticket. And if we were using an override state sourced system, we might not know that tickets were transferred at all. Maybe there's some tracking of it in some transactional thing because maybe there's money involved, but maybe not. And maybe all we know is that, well, customer C now has B's tickets, but we didn't know that B originally owned them unless we go look at the payment history. And so sometimes you can recreate some of that history by looking elsewhere because maybe there were side effects, right? Like payments, but maybe you don't have that. You may also want to know not only just how many customers are doing it, but when are they doing it? Are they doing it the day before? Does that tell us maybe there's some scalping going on? Right. And so there are all sorts of questions that you might not think of at the beginning when you're designing how data gets stored and how this information gets stored. And you may decide we need to know this, and now you only know going forward. And you might have to do some invasive changes, and that can be really time consuming and effortful to do. Since they're all immutable and you never delete events, you never lose information. Now, of course, if you never created the event in the first place, obviously you can't you can't retain it. which is why when you design events, you obviously need to, at a minimum, have the events needed to recreate the state, because the state is purely coming from events. There are some other things that are interesting. Whether they're how useful they are is another question, but you can see the state of the system in the past. And I'll actually demo that. You can say, what was the state of the concert a month ago? What events happened after that? And then there are different kinds of projections. So as I mentioned, the entity or the aggregate itself is a projection, right? We to load into memory, we basically played a bunch of events. The events that we played were specific to that identifier, right? Concert with this identifier, load only those events and replay them. But sometimes you want information that's across aggregates, right? I want to find out, I need to see all the sales. And so that is a different kind of way of looking at the events. It's a different projection. And these projections are another huge part of the event sourcing. And again, we'll look at that. So I want to give a quick run through from a domain-driven design tactical patterns point of view, just so that when I'm talking about the different parts of the different patterns, aggregate, and so on, you know what I'm talking about. So these are the ones that are important because these are the ones that have to do with persistence, right? So we've got entities. These are the things that have identifier and change over time, value objects, aggregates, and repositories. So entities are unique, right? We identify them through identifiers, right? So a concert has a unique identifier. Even if the same band is playing the same venue 3 nights in a row, they are different. Each concert is different. They have history, but if you're not doing event sourcing or not specially writing out an audit trail, you actually kind of lose that history. But you know there was history. You just don't know what it might have been. Value objects are descriptors, right? So they're immutable. They don't have a separate identifier, right? The number 100 is a value object. One value of 100 versus another value of 100, we don't care about the difference. So these are the things that are often used inside entities to quantify, describe, and measure. So how many tickets are available, what the ticket price is, those are all value objects. And so an aggregate is a consistency boundary. Perhaps it's just one entity with a bunch of value objects, or perhaps it's an entity that has other entities, and then those have value objects. So you might have 2, 3, 4 entities that consist of an aggregate. So a concert might be an aggregate. All of the tickets purchased transactions, maybe you store as a list of those. So you've got basically kind of line items of ticket purchases for the aggregate. And you need those perhaps to find out, am I allowed to buy more tickets? And so often we refer to the main object that we talk to, like concert, as the aggregate root. So this is just a diagram to show we've got 2 aggregates here. We've got an order aggregate and we've got a buyer aggregate. The buyer, there's just one entity. It has some attributes. The order aggregate actually has 3 objects. The aggregate root, which is order, an address, which is a value object, and then an order item, which is an entity, but also has value objects of itself. And so we don't just go in and modify address, we probably replace it, because value objects are, I always think of this, these small throwaway things. We can easily recreate them or create new ones and throw old ones away. And so if we want to find out who placed this order, the only thing we have, the only connection we have is an identifier. And so this is, if you've done domain-driven design, this should be common knowledge of aggregates refer to other aggregates through their identifier. And then the repository, it's responsible for storing and retrieving aggregates. So when I want to load an order, I don't load order items, I load an order. And then order items get pulled in with that. And so repositories are used for storing and retrieving aggregates. So aggregates to me are still useful, although there are some folks are finding that aggregates are too rigid in the world of event sourcing. But we can totally use the same idea and the same structure with event sourcing versus overwrite state sourcing of our data. So aggregates combine those two things. One is, how do I get the current data? So how do I project those events? So it has ability to project, right? So again, fold over, accumulate, aggregate over all the events, replay them. That's a projection of data. And then it has what's sometimes called the decider, the thing that actually makes the decision. So there might be one method, there might be a dozen methods that are making decisions based on the current state, the current projection, or the current projected state, right? So it's making the decisions of, do I generate an event or not, based on the command and the current state. So it's always replay, project to get the current state, then execute or attempt to execute a command. And then out of that is not a completely new state. It's just, here's the little bit that changed, stored as an event. So I want to touch on some misconceptions or confusions, not necessarily misconceptions per se, but often are sort of conflated. And one is event-driven architecture. Event-driven architecture is much more about how different systems collaborate and integrate with one another. And so I call these events, sometimes they're called public events. I tend to call them collaboration events, because usually they are, sometimes they're almost commands, like, but then they're no longer events, they're really messages. And so all these kind of get conflated. But event-driven architecture is just, how am I organizing multiple systems or multiple parts of a system? How am I communicating and collaborating across these module boundaries? Events and event sourcing are private. Nobody should be looking at those except projectors. And right, an aggregate is a special kind of projector, right? It basically loads all the events for its identifier. Nobody else should be looking at those events, because those are our private internal event sourced events. They may change, right? I may decide, hey, that concert rescheduled event is no longer sufficient because we needed to store an additional piece of information that we didn't store before. And so I'll now have a different concert scheduled event. And there are various ways to version that and change schemas. But the fact is anybody relying on how those events are stored for event sourcing, that's what Kononov would call intrusive coupling, and that's bad. So event-driven architecture, you're designing these events, and sometimes they're called domain events. And the problem with the word domain events is often they're used both to talk about event-sourced events and also these integration or collaboration events. And so I don't use domain events as a term by itself, because I need to communicate, is this something private to that aggregate, or is it something that I'm explicitly making more public for collaboration? So George asked an earlier question about addresses. We throw them away because they're easy to create. We wouldn't reuse them. That's one of the things about value objects, is we tend not to reuse them because there's no way to point to them. They don't have an identifier. If you were picking from a pool of all possible addresses, which there are systems that do that, right? E-commerce, you might start typing your address and it autofills it, maybe using a Google or some other API. Then you have a fixed identifier associated with that address, right? And then it becomes an entity. So CQRS is often associated with event sourcing for good reason, but it is not a requirement. It's not a requirement either way. in the sense that event sourcing does not require you to do CQRS per se, although it certainly leads you in that direction. And CQRS does not require that you use event sourcing. In fact, I've implemented CQRS without it, because what CQRS says is we're going to have separate read and write paths, right? We're going to optimize for separate read and write paths, perhaps because we're heavy writes and we want to optimize for that and get those written and persisted as quickly as possible. And maybe a little bit of a delay, what we often call eventual consistency on the read side, or vice versa, or both, where we have a few writes and lots of reads, and so want to optimize for that. And we do that with our current systems, right? So it might be time consuming to load up a bunch of data because of joins, and it's a lot of information. And so what we typically do is we cache those in some way. We might set up an explicit materialized view in a database to do that for us, or we might use an in-memory cache or Redis or something else. But we're always trying to optimize for read, if that's what the system is meant for, right? Because if we want to show here are the concerts that are available, if we have to go and search through all of the concerts in the database and all the times and all the places and all that kind of stuff, well, if we're constantly doing the same thing and that's time consuming, what do is we cache that. And whether we cache it in memory or in a database, but we're basically restructuring the data because A, we don't need all of it, and right, because there's stuff that's inside the concert data, like what equipment does a tour need? We don't need to know that for showing which concerts are available for sale. And in fact, we don't want to have to then filter out ones that are in the past. So we might even update that on a daily basis, right? So we're optimizing for being able to quickly show which concerts are available. But then they're limited by which ones have tickets. So maybe we have some extra work to do there. But we're always doing that kind of thing. All right. So let's take a look at JRTix. So this is my event source ticketing system. Let's take a quick look at the design. So let me switch over to here. Not that, but that. So what we've got here is we've got concert. It's an aggregate route. It has a couple of value objects, artist and venue. It also has tickets remaining, which could also be a value object. There's some other information that it has. And then we have customer, which is a separate aggregate route. It may have ticket orders. Ticket orders have tickets, but they point via the ID to the concert, so we know which concert you want tickets for. And what I have down here are sort of what you might call use cases or user stories, or simply tasks. So promoter, or the one who's running the venue, would create the concert. They might reschedule it. They might cancel it. All these kinds of things the promoter does. Customers buy tickets, and they may transfer tickets. And then we have views, right? These are the things that would appear on a screen. So we might have the concert status view that the promoter can look at that tells us information about the event, artists, and so on. And here it's combining two pieces of information: the core information from the concert, and then all the information about sales. And then we have a view for customer. I can look at my, what tickets do I have for which concerts? And I might have multiple events, concerts that I bought tickets for. So if we look at this from, and I'm going to use a very event modeling like way of looking at some user interactions. If I want to buy a ticket, I'm a customer. So probably use, here I'm using a web app, and so it's going to do a GET request. On the back end, it's going to do a query for give me all of these concert projections right? Give me all of the concerts that are available for ticket purchase. And we're going to get a read model. So this read model is, again, right, optimized for this specific use case of presenting concerts that are available to buy tickets for to a customer. And then they want to perform some action, like I want to buy tickets for one of these concerts. And so we then do a GET request to get details about the concert, right? So here we didn't have all of the details, right? We may not have even bothered to load up ones that are sold out or differentiate between that. We just load them all up, at least all the ones in the future. And then we get to, so we query for details of this concert, and likely here, we might load up the aggregate, and then we display it, and it's like, how many tickets do you want? And then you click complete purchased. If you implement your system with reservation, like most large ticket vendors like Ticketmaster and Live Nation do, when there's lots of contention, you might lease the tickets for a certain amount of time, but our system is meant for smaller venues that don't do that. So you complete the purchase, it does a post, which generates an event, right? Because I just clicked the buy, sidestepping all the payment stuff, assuming that that worked, we will generate a ticket sold event. From the point of view of the concert sold a ticket, or multiple tickets perhaps. In addition, the customer purchased tickets. So remember I said commands generate events. Sometimes they generate events across multiple aggregates. But when the concert was scheduled, a concert scheduled event was created that was specifically targeted at that concert aggregate. But here we're actually doing both, because we're basically saying, in a sense, there's 2 points of view that we need to record facts for. We need to record a fact for the concert that some tickets were sold. In addition, we need to record a fact that this customer purchased those tickets. That's done as a transaction, but it's not a cross-table transaction. It's a single table, because we're just inserting 2 rows when we persist this. And then as a result, we do a query against the customer store to find out what the ticket order was. We retrieve that information, and then we display it. And so from a high level, one of the things that this event modeling like diagramming gives us is a sense of, what do we see on the screen? What do we need to see on the screen? Right. So intentionally, this kind of modeling is intended for user-based interactions. We see these swim lanes for the different aggregates that are involved, and then we see the events that get generated as a result of each command. So this is a command right here. It causes 2 events to be generated, and then those are stored in the event store. And we see these different green ones are different views, and these are optimized for those use cases. And here we see a separate read model. This is a projector that is not associated with an aggregate. It's not looking at a concert with an identifier. It's not looking for a customer with their identifier. It's looking across all concerts. What were the sales? And that's a separate projector. And the way this projector gets generated is basically replaying all the events and then updating things that it cares about. So everything is always about scanning through events and then accumulating, folding, projecting, applying, whatever term you want to use. I like projecting. We now project a certain state. All right, so let's dive into the code. Actually, before we dive into the code, let's actually look at the application. So we can see which concerts are available. This would be the listing of available concerts that a customer can purchase. Real system would have something a bit nicer and a bit more information, but this is pretty much the information you want to display. You'd probably not show the concert ID, but that would be embedded inside of the thing, so that when you click the buy tickets button, it knows which concert you're talking about. But we have information about the artist, the date, the time, and the ticket price. And so we can go ahead and buy tickets. It shows us when it is, how much it is, how many tickets we want to purchase, and we can go ahead and purchase the tickets. And it tells us, right? And so this is basically the implementation of that diagrammatic flow that we saw before. And so what we can do is we can look at the events. So let's look at our concert events. And let's look at the one for the sonic waves. And so here we see bottom up, the bottom-most event is the oldest, the one at the top is the newest, and we see on the right the current projected state. So all these events happened. This is the projected state, right? There are 78 tickets remaining. This is the show time, and this is when the doors open. And so we can look at the individual events. We can say this was the original event when the concert was scheduled. We can see that the date was December 20th, and the doors were opened at 7 p.m. So we can see that that's different. How do we know that that is why that's different? Is there was a concert schedule, rescheduled event, defining the new show date time and the new doors time. And then we can look at the tickets sold events, and this tells us there were 8 tickets sold, and then 4, and then 2, and then 1, and then 2, and so on. And so we see the history of these things. We can say, well, what was it? What did the state of the system look like before that? So we can time travel. We can say, show me the state of this aggregate at this time period. And so now we see the original. What was it like when it was originally scheduled? Right? 100 remaining tickets. This is the date and time. And we can say, well, okay, what happened after we applied this one? Okay, we can see the date and time changed and the doors time changed. And then we can apply, oops, come on. There we go. Right, and so as each event gets applied, we see that the tickets remaining are being reduced. And so this ability is to sort of go back in time and just see what the state of the object was at different points in time is possibly useful. It's certainly useful for getting an understanding of how did this entity change over time and seeing what caused it to change. And we can also look at other projections, right? Other aggregates from their projected point of view. Whoops, I want to look at customer, and we'll look at first customer. So we can see the customer registered, right? At that point in time, they didn't have any ticket orders. They placed a couple of ticket orders, so we can say what was their state as of when the first ticket purchase happened, and then we can look at the state, which is now the current state. And so we see all of our ticket orders, right? There are 2 ticket orders, there's one here and one here, and other information about the customer has not changed. So these are the projections of entities, of in this case, of aggregates, right? So we load the events, we rebuild it, and we can see how the state changes. As I mentioned, there's a different kind of projection, which is more like, I want to see what are the sales. And so here we can see the concert sales report. And so this is generated by basically a projector listening for events that it cares about. This one doesn't care about customer events. It only cares about concert events. And it might also be that you limit it in time. So you don't care maybe about concerts that happened last year. Or maybe you want to show monthly reports. And so this projects, right, basically applies all of the events, all of the concert events, so including reschedules, all the ticket sales, and basically we see the Sonic Waves is selling, nobody else is selling. Hopefully there's a good reason for that. And so we can see that information. If we decide that we want to see additional information, like sort of what is the rate of sales, right? We can write another projector. Or we can maybe say we're going to replace this one with monthly reports. And so throw away the projector and write another one. And so the projectors are very much, how do I want to look at the data in a way that's convenient for viewing? And it might not just be for viewing on a screen. Often this is your integration point, right? So remember I said before, other parts of your system and other systems should certainly not be looking at the events, the raw internal event-sourced events. That's a no-no. But projections would explicitly be for sharing. So maybe another system needs to see some information about the current state of things. And so you can project that onto a separate table that then would be explicitly shared. And that's your contract to share it. And you know that it's being shared, and you know that nobody's going to muck with it. The only thing that writes to it is the projector. Everybody else reads from it. I'll get to your question in a second, Marcus. So you can have all sorts of different projections. When you create new ones, what's nice about it is you basically start it up. It goes through all the events. Maybe it takes a little bit of time to get its initial projection, because maybe it has to process a few thousand events. But now you've got a new projection. You don't like it, you throw it away. You want to modify it, you throw it away and create a new one, or basically just create a new one and deprecate the old one. And so you have all these different ways of viewing the data. And again, you could say, hey, we want to see this. Well, we've got all the events that created the state, so we can now go ahead and view it. So Marcus asked about, would I use event sourcing for every app? And honestly, yes. Unless it truly is like I am allowing people to edit data directly with little validation and almost no business rules, in which case I would just code generate that thing. But if there's any non-trivial state changing things, right? Non-trivial rules, non-trivial, and where I would be applying domain driven design, my default is now event sourcing. Not to mean I won't do something else, but that's my default. If I'm integrating with, there's already a bunch, 100 database relational tables that we need to interact with and access, then I probably wouldn't. On the other hand, you can do this on a per aggregate basis, right? So if you have a system and there's 25 aggregates, there may only be 5 aggregates where you ever think you'll ever care about events. And so each aggregate can be stored using what's best for it. So Sam asks, processing the events and projecting them in real time is too heavy. So this is often a question about performance. And so I'm going to group it under the general performance. This projection, for example, right now is actually running through all the events every time I view it. That's probably not the way you want to do it, but it might be good for prototyping. But why? But there's no reason to do that. You can store the projection. It's just data. And so the projection itself, even if it's only for viewing, you store it in a database table, just like you do anything else in traditional ways of storing information. In fact, that's the current code that I'm working on stream, is storing this stuff in a database. So instead of having to process through 100, 1,000, 10,000 events, you do that once when it's first created, and then it's now incremental. As events get generated by changes in other parts of the system, projectors become listeners to those events, and then they just update incrementally. They load all the concerts, apply the new event, maybe only 1 or 2 new events, and then do an update on the database. And that's super fast. And so this idea of and sometimes this is called a snapshot, right? So the idea of we only have to now, once we calculate the current projection, we now only have to calculate as the new events come in. And that's generally really fast because it's loading a few K of data, applying it in memory, which takes really no time. And then, right, your cost is basically persisting, loading some rows from a database and saving some rows to a database. There are no joins involved, so the database is going to be really quick. And so all your overhead is just loading and storing. And all the projectors are listening for these events and only applying the ones they care about, right? So customers registering, customers changing their email, the concert sales report could care less. And so it doesn't change. So Mark asks, recommendations for using event sourcing for clients sending data from time to time to a server. Can you elaborate on sending data? And feel free to unmute if you'd rather do that.
Sure. Thanks you very much for picking my question. I'm thinking about a client maybe on a mobile phone where you can enter your data until the data processing is finished, and then you send it off to the backend server.
So it's doing some processing locally and then sending something?
Exactly.
Okay. So, I mean, that from the backend point of view, that's very CRUD-like, right? Because it's not executing a command. It's just, here's some new data. I mean, you could use event sourcing for that and just say, you know, let's say they were measuring something. Here's the square footage update. You could do that. Probably not the optimal fit because one of the things that event sourcing kind of leverages is the idea of a little bit about why, or more than just, you know, let's say I'm measuring an apartment to move into, and I measure the square footage and all the measurements are done locally, and we just update something on the back end. And so it's like, okay, square footage updated. You could do that. It feels to me like that's not leveraging what event sourcing gives us, which is a bit more about business important events. So things like customers registering, buying tickets, where the decisions are being made on the back end is probably more in line with the strengths of event sourcing. And so just updating data. Someone in another context asked about sort of IoT systems, and they're just sending new temperatures. It's like, well, that's probably not useful because really we want to know the results of decisions that are made on the back end as opposed to just new data. So you could use event sourcing. The events wouldn't be very interesting. Not to say you don't get advantages from the other aspects. So being able to have different projections of views, you get some of that. You get some of the things around optimistic concurrency. But for me, that would be a weaker argument to go event sourcing than to just, why am I not just storing this data in a table?
Thank you.
Yeah. Yeah. So Fran says event sourcing makes sense when you can model user intent, right? So there's some actor, it might be another system, it might be a user that's taking action based on what they see on the screen. They're taking action, and then the backend is deciding whether that action is allowed or not. And I agree that very much domain-driven design and getting the event storming helps you get surface those events from the business. What does the business care about? And so I think that, and those are the kinds of systems I generally work with, which is why I tend towards my default now being event sourcing. But if I come to a data only thing, then I might rethink that. And again, right, you don't have to convert your entire system into event sourcing. You can say, if you've already got a domain-driven design, tactical patterns, and you're already using aggregates and repositories, your repository is your place to say, I'm not going to store this aggregate using a standard, basically state-sourced, you know, repository. I'm going to replace it, unplug it, and plug in. And not that it's necessarily that simple, but since the aggregate is a boundary, you can then say, I'm going to store this aggregate using event sourcing. All right, so now let's look at the code. So let me minimize that. So the first thing you need to figure out is your events, or one of the first things you need to figure out is your events. And so here, this is the hierarchy of events for Jitter Ticket. So there's a base event class, and all events need to have an event sequence, right? So they need to have a sequence so that when we rebuild it in the correct order. Order matters. Then we've got sort of a division between the aggregates that we're storing. So we have a whole bunch. We have two here, events associated with customer event. And so therefore, because it's a customer, it has a customer ID. Similarly, for concert event, it has a concert ID. And then each event has different details, right? So tickets purchased has a bunch of other details, connections to some ticket order and concert ID. Concert scheduled has a bunch of things. Tickets sold doesn't have as much, but we've got this hierarchy of events. So all events are going to have an event sequence. They're actually going to have, in addition, a global event sequence, because that way, for things like for non-aggregate projectors, like the concert sales summary, you want to be able to say, I have, what was my checkpoint? The last time I was updated was at this global event sequence. And then when it starts up again, maybe after a restart, or it got another event, it can say, have I seen this event? Its global event sequence is larger, so I haven't seen it yet. Let me process it and then update my checkpoint. So yeah, so George mentions distributed with sites that could be offline. And so there's a whole interesting area of conflict resolution. This is something I'm looking at. There's this area of what are called convergent or conflict-free replicated data types. And there's convergent, there's merging, there's other things that you can do that if one system saw events up to a certain point and another system saw a different event, can I just merge those? Right? And we see this with our version control systems, right? Sometimes the merges are like totally fine. There's nothing, they don't, this one changed data for this aggregate, this one changed data for this aggregate. They don't have anything to do with each other. They're independent. We can just merge those automatically. And CRDTs and so on are ways of defining, what is basically an ever-growing list, and ways of defining to handle those merges automatically, which helps with bringing everybody into sync when you have a distributed system. So that's a whole interesting area. I'm not going to go much deeper than that. So Hussein asks about a different event store table for a subset of aggregates. Now you're starting to get into some optimization issues, which I'll cover in a bit, but I want to get into a little bit more of the code. So one of the most important things is you have some kind of event store. And an event store, instead of saving an aggregate as a whole, it's saving basically what are the events that were just generated, right? So if we look at our use case, let's start there. Right, we've got a use case. What is the use case? Purchase tickets. So if we want to buy tickets, we need a concert ID, who's buying the tickets, and how many are they buying? Again, payment stuff all aside, assuming that goes through fine. So we grab the customer, and then we grab the concert, and we basically, on the concert aggregate, we say sell tickets to. And so behind the scenes, when we do this, it doesn't just update the state of that object in memory, it generates an event. And the event that it generates is tickets sold. And it enqueues it. So anytime an event gets generated, and so this is now getting into implementation details, when we execute a command and it succeeds, we enqueue it. And so all event-sourced aggregates have in common two things. One is enqueuing the events, and two is applying those events. So enqueuing does both, actually does two things. It saves the event because we're going to need to store it in our persistence, and it also then applies it to itself. So any aggregate event source aggregate is therefore going to have kind of four types of methods. Two you probably already have, right? You've got your queries and commands, right? Commands to execute things, queries to find out information. Then you have your event application. Pretty much your apply method is going to be where the action happens. Now remember, this is applying facts. So there's no decisions here. There should be like no business logic here. This is just saying, given an event that was concert scheduled, we're going to update our internal fields. For concert rescheduled, we're just going to update a couple of fields. For tickets sold, we're going to basically just update the available ticket count. No logic here about decision making. The decision that was already done when it generated the event. Right? So when we sold the ticket, we generated the event, we enqueued it, which again does two things. Holds on to it, what's called uncommitted events, because we haven't committed it to persistence yet. And then we apply it so that our internal object is now up to date in terms of its state. Right? Remember, I told you there are two parts. And so at some point then in our use case, right, it's going to basically save it. And so what happens with the save is it basically says, hey, give me your uncommitted events, and then I'm basically going to go and persist those uncommitted events. Right? So an action came in, we generated events, applied it to itself, saved it, and save says, what were the new events since the last time you were loaded? Right? So it's basically I'm just saving the diff. Persist that, and then we're done. And of course, at that point, we would notify our projectors, hey, go update here the new events since the last ones you've seen. And so from a testing standpoint, I tend to then divide my tests into these two sections. Commands generate events, events project state. So given a concert scheduled event, I want to make sure that given this concert scheduled event, that when I project or reconstitute those events into getting a concert object, that it applied all the stuff. And that if it's rescheduled, so here I'm basically scheduling it and then rescheduling it. And so my tests are dealing with and working with events. Create a couple events, basically apply them to reconstitute my domain object, and then check that it actually did that. So my tests are separating events update state from commands generate events. And so in my commands generate events, I can focus on the deciding, the decision, the business rules, right? This was all about, did I update the state correctly, right? The internal state of the object. These are the ones that are testing what I consider the behavior. And so now we can just focus on the behavior, right? So reschedule, and there's not a lot of behavior here. I don't have a lot of rules around this. In fact, I actually have no rules around this. Given the original concert scheduled, when I reschedule it, so now I'm executing a command, I expect it to generate a single event. So I can literally do that. I expect you to have generated a single event. Similarly, for purchase tickets sold, generate the event, call a method invoking behavior, and I expect it to generate a tickets sold event. Now, these tests are a little more verbose than I would like, and so one of the things I've been working on is creating a nicer DSL for this. Lends itself very much to it because there's a lot of noise in here when there's only a few things I care about, and so you can look at the code base for that. So we saw the event hierarchy. You can in Java, if I started out doing this as records, but records can't inherit from storage from parent classes, and so it's kind of messy. So I went to Java classes. It's unfortunate because with records in Java, you get some nice deconstruction patterns. With Java classes, you don't. But yeah, it's all things are trade-offs, right? So did the code walkthrough. Okay, so that's the bulk of this presentation, and now I'm going to talk about some little topics. If you have to drop off, no worries. The recording will be available. Go to ted.dev/talks. But I want to talk about a few things. One is versioning, right? Your events, just like schemas in our databases, sometimes we add new functionality and can use what we have. Sometimes we need to store new data. And so literally there is a book that consists of some of these patterns by Greg Young, no relation, who actually was the first who popularized CQRS and coined the term and event sourcing. And so there's a bunch of ways you can do this. I won't go into details, but there's ways you can do this. A lot of it's just about you're changing the content of events. Are they sort of backwards compatible or not? I sort of already mentioned CQRS, right? Separated data models, and CQRS again fits very nicely with that because you got your write API, and it's just emitting events and writing those out, and that's all it's doing. And then your read API, you're reading either from the aggregates or from projections, and so you may have specialized places to store these projections. Maybe they're just a table in a database, maybe they're in memory, who knows, but it's optimized for exactly what you need when you want to look at it. So I showed my little diagram of event modeling. Event modeling is a whole thing. Again, really useful if you have basically task-based UIs, right? Where you're going to present information. It's going to generate a command. The command generates events, results in an updated view of current state. We show that, and then we, again, execute, generate an event, update a read view, and so on. And so this kind of diagram is really nice, especially with the color-coded little post-it kind of things. You can really see what's going on. How does this get, where does this get the data from? What data changes, and so on. So this is courtesy of Yves Golevin on LinkedIn. He writes a lot about this stuff. I've learned a lot from him. He was also the one who mentioned the CRDT stuff that I've been looking into. So recommend you follow him. So that's it. That's event sourcing from scratch. I hope that it gave you at least a taste of event sourcing and what it can do. And I really feel like it's my default now. The mind shift is the hardest part to change, right? If you look at the code for this code base, and the links are on a talks page, it's not that difficult. The implementation isn't that complicated. The biggest part for me was the shift to, I execute a command, and now the state is immediately changed sort of in one big thing. Now we're splitting that into two parts. And the idea that you don't look in the database, the event store, you look at the projections if you want to look at what the current state of things are, or if you want to aggregate information. Mark, when I post this presentation, I'll have links to Yves Go 11. It's basically Go 11. You can look for him, but I'll post all details and links and stuff like that on the talk page. So you asked, how do we handle concurrency in a command, maintain a unique constraint for usernames? So for something like usernames, that's part of the decider, right? There's kind of no difference in your decision. It's just where you're getting the data from. So you would likely have a special projection that's just usernames. Just usernames. And then you might even have that in memory if it's something that happens often enough. And so you basically, as part of your use case, right, the first thing you do, and it's kind of part of validation, is you go and see, is there that username in the database? Now, there's obviously some concurrency race conditions that are potentially there, but the projection will always know what was the last event it saw, right? It's the global event sequence, and so it knows what was the last one it saw, and you can say, "Are we up to date?" When we try to write it out. And so all projections are going to be serialized in one way. They may be just stored in memory. Likely, you're going to serialize or store, persist, if that's what you mean by serialized, your projections, right? So my sales summary projector currently is an in-memory version. The one I'm working on my live stream is actually storing it in a database. And so the, what's nice about this is it gives you that control. Most traditional systems have this as well. For things you need really quickly, you might have an in-memory cache, right? That you use often, that you need quick access to. So it might be something that you have in memory. And if it's not a lot of usernames, then you might just store it in memory because it's easy. When the system starts up, it's going to replay all the events, looking for customer registered events, because that's where the username gets defined, and then accumulate those. If there's a lot of those, it might take some time. So you might just write it out to a table, or to another database, maybe like a Redis, if that's faster. Although I'm a big believer in sort of use Postgres everywhere. And so again, because we're not storing the latest state in the database in traditional relational structures, we can't and don't rely on database constraints to enforce things like unique emails or unique identifiers. So we need another way to do that. But with event sourcing, you basically project, here's all your usernames. You project, here's all my email addresses, and then you can optimize for that. What other questions do y'all have? And if you need to go, just drop off. I'll send out a link to the recording and information page, but you can always go to ted.dev/talks. So I'll mention performance just a little bit more detail. It's not an issue. If it is an issue, there are ways around it. Snapshotting, so you don't have to process 10,000 events. But businesses tend to have a natural time period, right? Like in accounting, we used to close the books. Why did we close the books? So that we didn't have to sum over all the transactions for the entire year. We closed them quarterly or monthly. And then we basically now store the summaries for that month, and we don't need to look at the transactions again, unless we find something wrong, in which case we can go back to the transaction. Same idea here. Any other questions or thoughts? All right, and thank you so much for coming by and watching and asking good questions. Really appreciate it. As I mentioned, the recording will be available probably later today. Slides and links to stuff will be on the site. So if you go to ted.dev/talks, you'll see that. And as I mentioned, if you're interested in watching me further code some of this stuff and introduce other projectors and so on, I do that on my live coding stream, jitterted.stream. If you're not in my Discord, go find out about it. We talk about this stuff. We have book clubs and other such community kinds of things that I think are really good. Just go to ted.dev about and you'll see all the information there. So that's it. Thank you so much for attending and hanging out, and I will see you next time.